Welcome to Deep Dive, the podcast where we explore the depths of science, technology, and the human imagination. I'm your host, Amy. Today, we're venturing into the cosmos to discuss a bold and ambitious vision for the future: building a colossal particle collider in space. We'll delve into what we hope to achieve with such a monumental project, how we might accomplish it, including funding as a global initiative, and the potential risks, like the accidental creation of black holes and their unsettling implications as weapons. Buckle up. This is going to be a thrilling ride. Let's start by setting the stage. Particle colliders like the Large Hadron Collider have been instrumental in advancing our understanding of fundamental physics. They've helped us confirm the existence of the Higgs boson and explore the standard model of particle physics. But these Earth-bound colliders have limitations: physical size constraints, energy limits, and geopolitical challenges. As we watch rockets launch into space, expending massive amounts of energy just to break free from Earth's gravity, it highlights how primitive our methods still are. So, what if we thought bigger? Much bigger. What if we built a particle collider in space? Imagine a particle collider so vast it encircles the moon or floats freely in space. By building a collider in space, we eliminate many of the constraints we face on Earth. There's unlimited room to expand, no borders to consider, and the vacuum of space provides ideal conditions for particle acceleration. But what do we hope to achieve with such a massive collider? The primary goal is to reach energy levels far beyond what's currently possible, unlocking new physics beyond the standard model. We could probe the mysteries of dark matter and dark energy, explore extra dimensions, and perhaps even uncover the fundamental fabric of spacetime itself. This isn't just about satisfying scientific curiosity. Discoveries at this level could revolutionize technology. Imagine new energy sources, materials with unheard-of properties, or even breakthroughs that make concepts like anti-gravity feasible. The implications are as vast as the universe itself. Now, let's talk about how we might turn this grand vision into reality. Such an undertaking would require unprecedented levels of collaboration and resources. Funding could come from a global initiative, where countries around the world contribute to a common goal, much like the International Space Station, but on a grander scale. By pooling resources, expertise, and technology, we can distribute the costs and benefits among all participating nations. This could be humanity's project, a collective step forward in our understanding of the universe. Technologically, we'd start by establishing a base on the moon. The moon could serve as a resource hub, providing materials and energy needed for construction. Its lower gravity makes it an ideal place to launch materials into space. We could mine lunar resources for building materials and generate energy using solar farms on the lunar surface. Advancements in robotics, autonomous construction, and in situ resource utilization would be critical. We might employ 3D printing technologies to fabricate components directly in space, reducing the need to launch heavy materials from Earth. Using the moon as a launchpad not only makes logistical sense but also serves as a testing ground for sustainable living in space. We could practice basic terraforming techniques, develop life support systems, and test habitats, all essential for long-term space missions. This lunar base wouldn't just support the collider, it would be a stepping stone toward becoming a multi-planetary species. It would help us refine the technologies needed for future missions to Mars and beyond. Now, let's delve into the potential risks, specifically, the possibility of creating a black hole. In high-energy collisions, there's a theoretical chance, however small, that micro-black holes could form. Most physicists believe these would evaporate almost instantly due to Hawking radiation, posing no threat. But what if we're wrong? A black hole the size of a golf ball, if stable, could start consuming matter around it. In an environment with enough material, like Earth, this could be catastrophic. That's why conducting these experiments far from our planet adds a layer of safety. By placing the collider far away in space, or even near the moon, we minimize the risks to humanity. This brings us to a darker aspect, the potential weaponization of black holes. It's a chilling thought, but if a civilization possesses the technology to create and control black holes, they might use them as weapons. A black hole could, in theory, be directed toward a planet or a star system, causing unimaginable destruction. While this sounds like science fiction, it's a scenario that underscores the importance of ethical considerations in scientific advancement. As we push the boundaries of what's possible, we must also grapple with the moral implications. International regulations and treaties would be essential to prevent the misuse of such powerful technology. Returning to the question of funding and collaboration, how do we mobilize the world's resources for such a monumental project? The key lies in highlighting the universal benefits, advancements in science and technology that could improve life on Earth, stimulate economies, and inspire future generations. Organizations like the United Nations could play a role in coordinating efforts, ensuring that even smaller countries have a stake and voice in the project. Private enterprises and philanthropists could also contribute, driven by the potential for technological spin-offs and the prestige of being part of a historic endeavor. Crowdfunding on a global scale, public-private partnerships, and international science grants could all be part of a diversified funding strategy. The project could create jobs across various sectors, from engineering and robotics to environmental science and ethics, making it an attractive investment for many nations. So, where does this leave us? Should we build a colossal collider in space? Many argue that the scientific benefits outweigh the risks. By advancing our understanding of the universe, we open doors to new technologies, energy sources, and perhaps even revolutionize space travel. However, we must proceed with caution. International cooperation, strict safety protocols, and ethical guidelines will be crucial. This project would require not just scientific and engineering feats but also diplomatic and legal frameworks to ensure it's carried out responsibly. It's not just about what we can achieve, but how we achieve it. The collaboration itself could foster greater unity among nations, proving that when humanity works together, we can accomplish the extraordinary. Ultimately, the idea of building a space-based collider is more than a scientific endeavor, it's a testament to human ambition and our innate desire to explore and understand the cosmos. It represents a collective leap forward, pushing beyond our current limitations to unlock the secrets of the universe. As we gaze up at the stars, let's remember that every great achievement starts with a bold idea and the collaboration to make it happen. Perhaps one day, we'll look back on this moment as the beginning of a new era in human history, one where we came together to reach for the stars, both literally and figuratively. Thank you for joining me on this deep dive into the possibilities and perils of building a collider in space. If you enjoyed this episode, please subscribe to our YouTube channel, like this video, and share the video with your friends. Let's keep the conversation going about how we can collectively shape our future. Until next time, keep exploring the unknown. I'm Amy, and this has been Deep Dive.